This is problem 13 in chapter 6, where a propeller is rotating at 1200 RPM. It has a diameter of 2.3 meters. The first question is, if it's rotating at 1200 RPM, what is the angular acceleration in radians per second? So this is just a unit conversion problem. That's 1200 RPM is revs per minute. We're going to get rid of minutes by multiplying by 1 minute divided by 60 seconds. And we're going to get rid of revolutions. 1 revolution is 2 pi radians. When you calculate that out, you get 126 rads per second, where each radian is an angle of about 57 degrees. So 120 revolutions per minute, RPM, is equal to 126 rads per second. The second question asks, what's the linear velocity of a point on the end of the propeller, instantaneous velocity in meters per second? The velocity equals the radius times the angular velocity. So this equals, the radius is 1.15 meters, half of 2.3 meters, times 126 rads per second. And that equals 145 meters per second. So pretty fast. It then says, what's the centripetal acceleration, A sub c, which equals v squared over r and that equals 1.82 times 10 to the 4th meters per second squared. So it's really accelerating fast, which means it's getting pulled into the center of the circle very hard. The last question says, well, what is that number in terms of its relationship to g's, 1g being 9.8 meters per second? So really what they're looking for is the ratio of AC to G. So we just divide the angular acceleration in the centripetal direction. Sorry, the centripetal acceleration, we just divide that, and we get 1.85 G times 10 to the 3rd G's. So it's a very strong acceleration.